Alrighty, for this question, estimate the area under the graph f of x over the interval 0 and 1 using the trapezoidal rule. So we have this graph over here, this little chart, and we want to use the trapezoidal rule. So what is the trapezoidal rule? So it's to find the area under a graph, right? So a equals 1/2 over b a over b minus a all over n. I'll define what these are later. Then bracket the first y initial, plus the final y, plus 2 parentheses the first y, plus everything, all the other y's that go in between, and then the final y, right? But this is a different kind of final y. I'll explain that in a bit. So, and then just close out with the bracket. So what does the b and the a and the n mean? So the b equals the final n, or the last x value, right? So it's the last x value, right? So now the a equals the first x value, and the n equals the number of trapezoids, in the graph, right? So how do you know the number of trapezoids in the graph? So look at the ordered pairs, right? We have 0, 1, and then all the way over here we have 1 pi, right? So we have 1 ordered pair, 2, 3, 4, 5, 6, right? So we have 6 ordered pairs, and that means we have 5 trapezoids in between these ordered pairs. So the general rule of thumb to understand is that the number of trapezoids is 1 less than the number of ordered pairs there are. So over here there's 1, 2, 3, 4, 5, 6 ordered pairs. That means we have 5 trapezoids. So n equals 5, right? So n equals 5, right? So what is b? The b is the last x value. So here we can see that b equals 1. What is a? A is the first x value. So a equals 0, right? So now we have our values, right? At least we have the values for b, a, and n. And these over here, these y's, we can go with that in a bit. So now let's start substituting for some variables, right? So we have the area equals 1/2 times b, which is 1, 0, all over 5, and now we do the bracket, right? So the y, like this first y, this is the first y value, right? First y value can be seen over here. So 1, and now this yn, that's the last y value. That's the pi. So you can put that as there, right? Now bring down the 2, so plus 2, parentheses. Now this is the first y value in between the first and the last. So this y1 is talking about that, right? And these little dots are talking about these values over here. And the very last one, what do you say? Yn minus 1, talking about that, right? So we can write this as pi that plus pi 0.3 plus pi power 0.5. Now for our last one, or oops, not 0. Last one is pi 0.7. Close that. Now close the bracket, right? So now we have this long strip of equation, right? Function, however you want to call it. So we want to plug this into our GDC, right? And be very careful as to how you plug this in, because you can easily mess this up. And doing all this work and taking up all this time to mess it up is not worth it at all. So we can do 1 over 2, and then we can do 1 over 5. Right, close that up. And now, be careful of the placement of your parentheses. Make sure about that. So now you have 1 plus, let's go with 2 actually, and parentheses. And let's put in that middle, that parentheses over here, right, with all those pi's. So and pi to the power of 0.03. Let's go plus pi to what? To to the power. Keep missing that decimal. To the power of 0.5, and then plus the final pi, which is pi to the power 0.7. Keep missing that decimal. There we go. Right, and then plus, and then don't forget the pi. I left the pi all the way at the end, just so it's a bit clearer for myself. So yeah. So now we enter it, and we get 4.2041 and all those extra numbers. So 2041, right? And then since we're always wanting to do 3 significant figures, this can be rounded off at 4.20, and that is your final answer.